Okay, this is sample exam 2, question 15. Determine the rate constant. And we have some experimental data here, concentrations of A, concentrations of B, and some reaction rates and molarity per minute. If you need more practice with this, check out my channel. This is a very common kinetics type question in college level chemistry course, and I explain it better and maybe slower and more thorough. Here I'm just taking you through the exam really quickly here, and if you need more help, you can dig through my channel for additional examples. So first, of course, you want to look for, let's look at A first, and let's try to determine the change in the rate based on the change in concentration of A. So let's find two reactions where it looks like the concentration of A is doubling. There's a lot of choices here, but we want to also make sure that B is constant. So it looks like reaction 1 and 3, the concentration of B is steady at 0.5, and it looks like A doubles from 0.5 to 1. All right, so we want to take the corresponding rates over here and do the division. So 3.4 times 10 to the minus 2 divided by 8.5 times 10 to the minus 3 is equal to 4. That tells us that the reaction is second order for this reactant A. Now, let's go ahead and do this same process for B. We want to pick a couple of experiments where it looks like the concentration is doubling for B. There's a lot of choices here, but we want to make sure A is constant. So it looks like experiment 1 and 5, the concentration of A remains the same at 0.5, but the concentration of B doubles from 0.5 to 1. All right? So we want to take that higher rate and divide it by the lower rate, and, well, the higher concentration divided by lower, and it looks like it just comes out to be 1. Okay? We'll go ahead and write out what's going on in my mind here. So I'm dividing the rates. I get 1. So that tells me that the reaction is 0 order with respect to B. All right? So all of this work requires us to figure out the rate law. And after all of this work, I have figured out that the rate law is equal to K, a rate constant, times the concentration of A to the second power, times B to the 0th power, which is just equal to K A squared. So let's go ahead and now finally work on the rate constant. The K is equal to rate divided by A squared. And we can use any experiment to plug in some values to figure out the rate constant. It should, after all, be a law and give us the same value no matter which experiment. So I'll choose the top row here as I have highlighted, times 10 to the minus 3. Molarity per minute is the unit here. And we divide by 0.50 molarity squared. Okay, when you work this out on your calculator, you get 0.017 per molarity per minute. Okay, let me double check the math here just to make sure. If you've got it, go ahead and end the video and go on. But yes, I've made a mistake. So that should actually be 0.034. Didn't seem right. All right, so 0.034. Let's go ahead and box that up. That's the final answer there. Thanks for watching.